infrastructure. Under this, we understood about app service. Why we need app service here? App service will help us to deploy our application. Whatever the application we have. So suppose, usually what we need, not suppose, we need infrastructure. If you don't have infrastructure here, what option you have? If you don't have infrastructure here, other than creating infrastructure, you can use a platform as a service here. If you use a PaaS, platform as a service, by default, that platform as a service will help you to deploy your application to the end user. And one more thing, we have seen this app service comes with the by default DNS, right? And our own DNS can be also configured. Own DNS also can be configured here. Another thing here is what we have. We have integration with DB, right? We have integration with the DB database. By default, we have integration with the DB here, right? Under PaaS, we need to understand this is. So what we need, of course, we need a package of application we need, that is called artifact, that we are going to cover in later stage as well. That is called artifact here. This artifact, if I'm saying about this artifact, or if I say package of application, we can deploy, we can add into app service. By default, this will be accessible to the end user by using DNS. But these things we will cover in later stage during DevOps. So this is what we need to understand from the PaaS, platform as a services. So as I said, what is our today's topic now? Today's topic is containers. Now today's topic is containers here. Now if I go to my cloud provider, if I'll go to my console here, from the console we can see, from the console what we can see? We can see the service name called containers. Under container, now container is a technology. Now if I say container, if I click on this section here, if I'll go to all service section, under this section you will see containers. What container is? Under container we have many services. But first we need to understand what container is, and I think many of you heard about Docker Kubernetes. So Docker Kubernetes works on a technology called container. So why we need Docker? Why we need Kubernetes? And why we need this cloud services for container, and what container is? That is our topic for today. So let's understand. As I said yesterday itself, this topic is little high-end, are in demand, because container technology is very advanced technology. So it's going to stay here for more duration, longer duration of time. What I'm saying here, I'm talking about container. I'm talking about a container here. What container is? First definition of container is nothing but container is a package of application. If I says what container is a package of application. Whenever you are talking, whenever somebody is talking about package of application, please remember what is a package of application. Yesterday we understood. Is it? Application package is nothing but source code plus library and dependencies. What container is? Container is a process of packaging or package of application basically, right? Another definition of container is nothing but OS level virtualization. Another definition of this container is nothing but OS level virtualization here. What do you mean by OS level virtualization? And what do you mean by package of application? Right? Third thing here, and we need to understand what was the necessity. Why container? What this is? What and why container technology? This technology came into the market. What is the logic? First definition is, what is a container? Container is nothing but a package of application. Package of application is nothing but source code plus library dependencies will be packaged together. Second definition is OS level virtualization. What do you mean by OS level virtualization, and what was the necessity of having containers? Let's understand that. First of all, what we need to understand here, we need to understand why. Why containers came into the market. Right? Why container? Why we understood let's package application by using container? Why? First, please remember application architect. How many type of application architect we have? Two. Microservices, monolithic. Now here what I said, there is a two type of architect. If I say first one is monolithic one, second one is microservices one. So second one is nothing but microservices one. What do you mean by monolithic, sir? Monolithic, single. What do you mean by application? I am saying application architect. Listen me carefully. What I'm saying? I'm saying application architect. If I'm saying application architect, what is application basically? Front end, back end, and database. So what is architect for that? In monolithic architect, there will be a single packet of front end, back end, and DB. What I'm saying here, single instance, single packet of application for what? Front end and back end and database. Single packet means package. Single package. Single packet. If I say single packet means what? Single packet means if there is a problem in single packet, what will be there? Suppose there is a problem in back end. There is a problem in front end. There is a problem in DB. What do you have to do? You have to open that packet. If you open that packet, end user will face downtime. End user will face downtime. Whenever we are creating architect infrastructure or anything, please remember there should not be a never ever should be a downtime for end user. If there will be a downtime, it will be problematic for us. That's why these banks, whenever you are going to the banks, right? What they are saying, today our server is not working. Please come tomorrow. Right? Why? Because of this thing. Their application integration is nothing but their application package is nothing but monolithic, single packet of application, front end, back end, and database. Because of that, as you can see the limitation here, because of that, microservices came into the picture. So they divided one entire application into what? Small services. What are the basic component of any application? Front end, right? Front end. Under front end, what we will have? On front end, then back end means what? We will have a API gateway, catalog. There we will put the catalog, add services, right? Add services, database will be there, right? So call, of course, contact services. So there are many. Means basically what microservices did, microservices divided your application into small services. But how your architect of microservices will look like? Let me show you that. No. That is different. Server is different. Don't go there. Server is different. Why you're adding server there? I'm talking about architect. Oh, come on, man. Code. Code will be sent to my account or where it will be sent it? No. It's not. It's GitHub. So they added MFA multi-factor authentication into GitHub also. Okay. So let me verify. Code they sent it to email or what? Two-factor authentication, TOP, or browser extension. Okay, I'll do later. Oh, he's not allowing me. Just a second. Otherwise, I'll add passkey. I don't have code. Use your password. I forgot my password, I guess. Let's see. Recently they added. Recently they added actually. Mhm. Actually, I need to install the application as well. My Gmail is also full. That is another problem actually. Yes, pass key has been added. This I got this message. Just give me a second. I need to authenticate actually. So this was unexpected. Here also I have problem actually. My mobile phone don't have enough this. Now what we need to understand. Now let's understand here. So just a second, I'll go another way. So what I'm so what we need to understand from here, we need to understand the architect actually. What I'm saying, this containers, this monolithic application divided into microservices here. So YAML, AKS deployment, repos. Okay, I did deployment from here. Right. Now this. I need architect for that application actually. Dev.azure.com. My Gmail is full. Yesterday you created app services in Canada. Cancel the deployment. When you receive the service again, why it's not allowing to create in same region? Jyoti, it's not allowed to create in same region because we have a restriction to create a database DB in one region under free tier. Right? What is a single packet? Single packet of complete application, front end, back end, and database. One packet. Code will be authorized to PP on mobile. Actually, I don't have space. This Shiv, because of that reason. Okay, just a second. Let me go here. So this is a YAML. Okay, cluster microservices deployment here. Oh, I don't have here as well. So where my project is then? Services don't have plus AKS cluster deployment. Oh, yes, I got finally. So now what you need to understand here, if I says here, now see here, what I have. If I go to this section here, now what I'm saying here, this is my reach. So what this is my entire application actually. Now see, what are the component of this application here? Interface. Yeah, this interface I'm looking for. Is it visible now? So now what I'm saying here, this is my entire, what I'm saying here, this is a entire application here. What I'm saying about the microservices. Please understand, this all together is one application. What I'm saying, one application. But how they created this by using microservices. What this is, front end different, ad catalog different, right? Recommendation service is different, product catalog different, shipping service different. If you want to pay in different currency, that will be different service. If you want to make a payment gateway will be there, email services, right? Cart services, where your catalog cart will be shown and it's attached to your DB database. So microservices means you break down this entire application into small service. This architect is nothing but microservice architect here. This architect is nothing but microservice architect here. Now, because of that reason, what happened? Because of this reason, what happened? Now, what is another advantage of using microservices architect here? This microservices can be written. Now, see here. Front end is written in, if I say front end is written in Go, if I says here, so now what I'm saying here, now see this architect here, under this architect, what we have? See the language in front. If I says front end is written in Go, cart service is written in C#, payment service is written in Node.js, email service is written in Python. What is the thing? What is the thing about this? Whenever you are creating whenever you are creating monolithic, package, this monolithic package can be created by only using single language stack. You cannot mix the stack. If you're using Java, you need to use Java stack. If you're using Python, you need to use Python stack. But what about microservices? Another advantage of using microservices is this microservices application these microservices can be created by using different languages. Nowadays, why one single organization is hiring different type of developer? It was not before. Why they are hiring different developer? Because architect is now microservices. Because of that reason, we need different developer from different language background and different stack background. So what I said, this entire application is divided into small services. These small services can be written in different language, and of course they will be connected with one another, right? They will be connected with the one another. Altogether, this architect is nothing but microservice architect. No, these are not called package. These are not called packets. Okay, services, you call them services. Single package. No. Don't call them package. Okay, call them services as of now. Call them services. Okay. So now what I'm saying about the services. These services will be connected with one another. What is the advantage now? Advantage is if your one service is not working, your payment is not working. So which will be down for the end user? Only payment section will be down for the end user. Means to troubleshoot, you no need to take down your entire application. You no need to take down your entire server, right? So whenever you are creating application by using microservices, when any service is not functional, so you no need to take down entire application. End user will not face downtime in this case. End user will face downtime only for that respective service. Now, another advantage is containerizing these microservices will provide independent environment for these microservices to run. If you are running these microservices within the container environment will provide very customized or independent environment for these microservices to run. Because of that reason, what people started doing? People started creating application containers. These microservices container inside the containerized environment, because container will provide very separate or independent environment for this package of that application to run, right? So means something like this, right? You have one independent room for yourself. Now feel what it will be, right? Feel it will be how it will be, something like that. Very independent environment. Because of that reason, which came into the picture? Containers. Let me revise. Why container came into the picture? Container came into the picture because architect shifted from microservices to monolithic to microservices. What do you mean by monolithic? Monolithic is nothing but single packet of application, and this single packet of application can be written by using single language stack. If there is a problem with your single packet, you have to take down your entire application. Right? What I said yesterday, artifact. I said artifact. What is artifact? Artifact is nothing but package of application. Package of application for what? Monolithic packet. Right? What we was creating there? We was creating front end and back end code for the from the developer, and we was creating a CI pipeline, build pipeline. We was creating. I shown you. I have not shown you. I just showed you theory. There, single packet of application. But if that single packet of application will have any problem, you have to take down entire application. You have to open that packet. Think. Single packet means you have to open. What is a single packet? Single packet of front end, back end, and DB. Right? So this packet you have to take down. If there is any problem here, you have to take down. Because of that reason, microservices came into the picture. Microservices is nothing but this entire application is divided into small services. So as it is divided into small services here, if there is any problem in any service, what you have to do? You have to take down only that service, because these are absolute independent from one another. They are running absolutely independently from one another. One we created from PHP, another we created from C#, another we created from Go, another we created from Python. Right? So these are absolutely independent. If you connect them with one another, they will work as a complete application. And microservices can be written in different language stack. So containerizing these microservices will provide very independent and customized environment for this application to run. Because of that reason, people prefer architect of microservices. Because of that reason, container came into the market. People started containerizing microservices. Right? So because of that reason. And second understanding. First understanding, this is what we understood. Then let me go to the second one. If you want to take, if people want, you can take a screenshot of this. Right? Monolithic single language and microservices multi-languages. Pawan absolutely pinpoint. Any example of monolithic and microservices? Microservices, Krishna, I have shown you. Monolithic architect I gave you, right? Monolithic I gave you. Architect I can give you. How I can give you example? Microservices example, Krishna, I gave you just now. I think I gave you microservices architect. That was application, right? So what was? That is application here. See, this is my entire application. What do you mean by this? This is application here. Something like this you will get. This is application here. This application architect is something like this. This is a architect. How many microservices we have? 11 microservices, right? This application is composed of 11 microservices written in different language and talk to each other by using gRPC. Understand? So this is what I am saying. What about single packet of application, right? Don't worry about that. Think about it. Okay. What is the use means? What I said just now. I said it will provide you a single packet of application, right? Means service. If you're putting microservices inside the container, means where it will run. It will run in very independent environment, right? What it will be? It will run smoothly. It will not give you bugs or vulnerability. Think like this, right? Right? Be very independent environment, no problem, because these microservices will not be attached with each other, right? It will not give you tension. Of course, it will run very smoothly, right? So this is what. So now let's understand others. What do you mean by OS level virtualization? What do you mean by OS level virtualization here? Now here there is a 3 architect you need to understand. I told you people to explore. What I am saying, what I have. Now here I am talking about OS level virtualization. What I meant by OS level virtualization now. So now what I said, I have application. What I have? I have application. To run the application, what I need? To run the application, what I need? I need library and dependencies. I need library and dependencies, and below library and dependencies, what I need? Operating system. I'm talking about on-premises. I'm talking about on-premises. What was the structure before? Application structure was on-premises before. What I'm saying? I'm talking about on-premises here. This is my hardware. If I'm talking about traditional on-premises here, right? Hardware wastage was big problem. As I said, how much we was wasting, I am taking on an average as per the observation written on the BAP. 30 to 40% of hardware component we are wasting. As I said, is it like this? What the provider said, don't use hardware component, I will not charge you money. If you're not using 50%, I'll not charge you money. Don't use 60%, I'll not charge you money. Is it like this? No. You paid upfront for each and everything. What I'm saying, on premises. If you're saying on premises, on prime, this was another major concern, and this is a major concern. What is a major concern here? Major concern is you are wasting a lot of hardware component, hardware resources. Because of that reason, what came into the picture? Hypervisor came into the picture, and this virtual machine works on a technology called hypervisor. But in virtual machine, what was the problem? What was another problem? Virtual machine will be installed. Now, what is virtual machine? Virtual machine is IaaS, right? Infrastructure as a service is you people are not practicing. Virtual machine is what? Infrastructure as a service is. Underlying hardware resources will be managed by whom? Cloud provider. So means whatever virtual machine you are going to create, you will create virtual machine on underlying hardware resources. So now your hardware resources will be utilized up to 100% of your potential. But problem was operating system licensing. OS licensing, let me give you example. OS licensing was a big issue. What was the big issue here? OS licensing was the big issue here. What came into the market? I'm lazy to draw because this is. So now what I'm saying here. So this is what I said. How many virtual machine we have here? 3. 1, 2, 3. Right? Here we have hardware. So what I'm saying, hypervisor came into the picture. Hypervisor enabled virtualization. Because of that reason, what we have, these hardware plus operating system can be utilized up to their maximum potential, full potential. What was the problem? How many licensing we need? 1, 2, 3, 4. On one host itself, how many licenses we need? Is operating system for free? No, they will charge. You have to pay for operating licensing, operating system licensing fees. Now here, what was the problem? What problem came? So in on-premises, what was the major concern? In on-premises, what was the major concern here? We was wasting our hardware resources 30 to 40%. But in case of virtualization, in case of VMs, we are wasting. We need to put money on OS licensing. So from where you started, you ended up there, right? Because of that reason, which came into the market? Container came into the market. Now what container technology is? What is a container? Container is nothing but application container. What do you mean by application container? Package of application, library and dependencies. Fair enough. So now what you need? If I say the container here, if I'm talking about container, in container, what we have? In container, if I say in container, what we have? Library and dependencies packaged together. Can I say like this, to run any application, I need library dependencies, operating system and hardware. If I don't have any one of this, I will not be able to run my application. Is it fair? Yes. So what I am saying, library and dependencies we have packaged together. What about operating system and hardware? Container don't have their operating system and hardware. So then how it will run? Let me revise again. What I'm saying, container don't have their own operating system and hardware. How they will do now? Container will have a container engine. What container will have? Container will have a container engine. Now what this engine will do? Now what this engine will do? Now think. Nitin, what I'll do? I'll hack your brain. If I lack your brain, you will follow me, right? Whatever command I'll give you, you will follow me, right? Similar way. Now, what this container engine will do, container engine, how many of you knows about kernel? You people knows about kernel, right? What is a kernel? Brain of a operating system, right? What is operating system? Interface between software and hardware, application and hardware, right? Middleman between. Software will give a command, requirement, it will take and it will hand over to the hardware. It will hand over those components to the software. Then what I am saying? I am saying what this engine will do, engine will directly interact with the kernel of operating system. Think logic. Who thought about this technology? Think about him. This engine will directly interact with the kernel of the operating system of whom? Host. Host. No, no. See my laptop. I have a laptop, right? I want to run a container in my laptop. But if I want to run the container don't have their own operating system and hardware, right? Container don't have their own operating system and hardware. What is a container? Package of application. That package of application need to run somewhere. If that package of application need to run somewhere, what the container of application build engine will do, you have to configure to run container, you have to configure engine. Why you have to configure engine? Because engine will interact with the kernel of operating system. Now, why he will interact with the kernel of the operating system here? He want this container to share. He want this container, he want this operating system to share kernel in different containers. So this container can be created on a host operating system and hardware. So means, what is the meaning of this one? Whenever, suppose I have a container, whenever you need to run any container, what you need? You need to configure engine on that container, engine on that where host. What it will do? It will directly take, it will take space from host. Let's take example of my laptop. My laptop is i7 processor. Mine is i5 processor, not i7, i5 processor. Now what it will do? And of course, my storage is, if I say HDD, it's 1 gig, 1 terabyte. So now what it will do? It will take, means container will be created where? Here. Container will be created here. Now how many container I can create? Now this question will be, how many container I can create here? Answer me. How many container I can create here? Where I'm creating a container first of all? I'm creating container on my host. Now, how many container you can create? It will depend upon host capacity, right? What is the host capacity? i7 processor with 1 terabyte, right? So according to that, it will be decided. What I'm saying, this is what. Yeah. What is gRPC? Forget about this Shalandra. Library, hardware, package of application, managing container, image, building, pulling and storing, Soumya, any number, depending on a host, any number. We cannot say Sundar that, right? One we cannot say, right? How many we can create? It will depend upon a underline host capacity, right? How many I can create? I can create more than 50, 60 here in my laptop. Understand? So cannot give exact number. Can I give? No. It will depend upon a hardware capacity. It will depend upon resource capacity. It will depend upon capacity of underlying host, right? This is what you need to understand. Listen carefully one more time, right? So this is what. So these things you won't get from many places in that systematical way within a span of 1.5 hours. And in a span of 1.5 hours. So listen carefully. I'm not saying you will not get, you will get, but you need to put extra hours, right? Not to put extra hour, you need to listen to me. What I'm saying, I'm talking about containers. Please understand, container is nothing but, it's called OS level virtualization. Why it's called OS level virtualization here? We understood what is OS level virtualization here. Because container engine will virtualize where? On which level? OS level. That's why it's called OS level virtualization. What I'm saying, what was the necessity of container? What is OS level virtualization? What is this? In on-premises, what is a major challenge here? Major challenge was hardware wastage. We was wasting 30 to 40% of hardware wastage, are wasting, was wasting, and will be wasting in the future as well. So because of that reason, which came into the picture, BM came into the picture. BM works on technology called hypervisor virtualization. What was the another challenge with BM virtual this hypervisors or BMs? To run this, what we need? We need extra operating system. So that will add extra costing to our budget. Because of that reason, container came into the picture. Container is nothing but one single packet of application. To run this single packet of application, what we need? We need engine. Why? Because container by default don't have their own engine. As they don't have their own engine, what this engine will do? As they don't have their own operating system and hardware. But if I say container, container is nothing but application. Application container, to run the application container, what do you need? Hardware plus operating system. That hardware and operating system will be taken by a container engine from where? From the host. I am taking example of virtual machine. Suppose I have a virtual machine. Let's take example. I have a virtual machine. I want to run container on virtual machine. What I have to do? On virtual machine, I have to install container engine. Container engine will virtualize. What it will virtualize? It will virtualize your what? It will virtualize your virtual machine. Now, how many container you can create in virtual machine? It will depend upon virtual machines, right? We are taking RAM, we are taking BCPUs, we are taking capacity. It will depend upon that. What this container will do? Container will directly interact with the kernel of the operating system of that. That is what it is, right? What about Docker? Docker is a name. What I'm saying, Docker is a name, right? Who works on a technology called container. What is Kubernetes now? What is Kubernetes? Kubernetes is provide orchestration, management for the container. Now what people started doing? People started creating so many containers. Everybody started creating container, microservices, container of application, container of application. Our population is almost 1.5 billion, right? I'm talking about world population is too huge now. World population, I'm talking about. Management has to be there. Otherwise, there will be resource, right? Resources will not be enough. So similar way here, people started creating so many container. Because of that, management of the container became necessity. Another Superman came into the market called Kubernetes. What Kubernetes will do? Kubernetes will manage the container, right? What Docker will do? Docker works. And what about cloud? You are talking about cloud, sir. Why you are going there as of now? What cloud? Cloud is also working on technology called containers. Understood? We understood till here, right? You need to listen this theory again and again, because this is little high-end thing I'm talking about. What is the equation for one container? How many CPU plus memory required? Rafiq, for one container, how much memory or how much is we required? Right? So let me take you there later. Your choice. You can create a multiple container. If you're creating multiple container means multiple instances. If workload is more, then what do you need to do? You need to create multiple instances, right? How to deploy a container to prod? Don't worry, Sundar. We'll go there. We'll go there. Don't worry. Stay with me. Stay with me, please. Rafiq, we'll go there. Don't worry. Okay. I'll show you how much memory it will consume and how it will. Listen to this story. Slowly, we'll go there. So, right, Sundar, don't worry. We'll go. Vivek, do we have any redundancy? Have such a setup? No, we don't have any redundancy factor here, Vivek. Right? Redundancy factor. Kubernetes will do management of the container means what exactly it will do? Sonali, management of the container means orchestration, scaling up, scaling down, increasing, decreasing, right? Fall in line, attaching services. Don't worry. Okay. For this, you need to listen Kubernetes, right? You need to spend around 8 to 9 hours, right? I think it will take this much. Okay, Sonali, don't worry. Stay with me, sir. Once again, Docker and Kubernetes. Don't worry, Pawan. We'll go into Docker and Kubernetes. One container will have one service, Akash. Yes, absolutely pinpoint. Akash, you are correct. Okay, don't worry. I'll answer you. You are thinking about future. That's what I was willing. Understand? I want you people to stress your mind. So we'll think why like this, how like this. The time I'll teach you Docker and Kubernetes, your question will be answered. But one more question. Yeah, go on, please. Mm-hmm. Who said can replicas? Can, can. Okay. That is the future. Yeah. So, uh-huh. Uh-huh. You can access. Both can access. Your host means not your laptop actually. We will not run on laptop. Never ever run on laptop. Where we will run? On a virtual machine. If you're running on a virtual machine, can you define RBAC for virtual machine? Yes, easy. Right? This is what. Now here, listen carefully. Now let's get more deeper into this. See, just now what I'm saying, I'm talking about container. Right? What I'm talking. Sir, you're talking container, but how we are going to create this container? We are going to create this container from a image. Who said? Ria said or Rafiq? Who said? It's who said this? Somebody asked me this. Uh, Riaz, I think, right? Rafiq. Yeah, Rafiq, you said to me, right? So how much space it will take? Please remember, container will take huge space. See, you are running application. Think application. If you're running application means it will take more space. If I'll take now roughly, if I'll calculate, if I say Python, Python will take around 3 to 4 GB of space, right? But now how you will transport from one place to another place now? See, I need to transport from one place to another place. To transport from one place to another place, what I will do, I will package that in the form of image. I will create the image I'll create and I'll pack it in the form of image. Why? Compressed archive. Compressed archive. How many of you have seen Transformer series? How many of you have seen? I think many of you have seen, right? Transformer series, right? Harshal, what is the difference between App Engine and Kubernetes? Why you are relating Kubernetes here? On both the container management, no, no. App Engine will provide virtualization. Container, forget about Kubernetes as of now. Okay. Kubernetes is used for container management. App Engine will create environment for container to create in a host. Understand? Basically, what it'll do. Now, Harshal, engine is your friend, right? What is your requirement? Your requirement is you need operating system and hardware. What it'll do? It'll tell to the engine. What engine will do? Engine will give you a operating system and hardware. That's it, right? Operating system and hardware. Now, you have so many container. Those container will be managed by Kubernetes. That's it. Understand? So what I'm saying, how this is created. Now here, in Transformer movie, what they was, how they are moving. They are moving from one place to another place, like an automobile, car. They are becoming car, right? They're moving from one place to another. Why? For transportation. For transportation, right? Image. Are they doing something whenever they are car? No, nothing. They are not doing anything, right? But the time they will become transformer, then action starts. So similar way, we have an image. From the image, we will convert container. Container means actual process for your application, actual task for your entire application will be within the container. But why we are using image for transportation? Why? Because image will have a compressed archive, very less size, right? Very less size. Size will be almost 10%, means 10% of whatever the size of container is, right? Why we are going to use this? For transportation from one place to another. What do you mean by image, sir? Images are in the form of layer. Runtime for container. What will be? Images will be in the form of layer by layer. What do you mean by layer by layer, sir? Base will have operating system, 5% of a operating system. Usually major times it's Alpine. What is Alpine, sir? Alpine is lightweight Linux OS. Okay, 5% will be then library dependencies, packages, source code, all this together will make what? Application. All this together will make one application. What application? Right? So that will be kept it in the form of image, right? That will be in the form of image. From the image, we are going to run a container, right? So that is OS operating system. Don't think about that. That is different. This is a container image. That is a OS image. Understand? Replicas. Understand? So then what I'm saying here, this is what. But where we can keep this image, sir? We can keep this image within the registry. Do we have any official registry? We have one registry called Docker Hub. We have one registry called Docker Hub. In Docker Hub, we can keep this image. We will find this image inside the Docker Hub. Now what you will do, you will take the image, you will run the container. You will take the image, you will run the container. You will take the image, you will run the container. What about this, sir? What about cloud? What cloud is doing? Cloud is doing the same, right? Do cloud have a registry? Yes, cloud have official registry. What that is called? I think many of you will be happy because many of you heard about that. ACR. Very, very important registry. Azure Container Registry, ECR, Elastic Container Registry from AWS, Azure Container Registry from Azure. What this container registry is? Container registry we will use to store what? Image, right? Why? Docker Hub is a private registry. It can be public or private registry. If you're creating something by yourself, you need that. You needed that to store in your own customized environment. So that is what you're doing here, ACR, right? So then, of course, there are more understanding. This is a very huge topic. Don't worry, right? You understood milestone here because why I gave this structure? I gave this structure because your story will lies here. What story, sir? We are talking about container services. So now think what cloud is doing on containers. Now here, think now. I have a container. What container is? Application basically. Application container. But how that application container you can put for the end user? How that application container you can put for a end user? That is a question here. We have a container registry and we have container instance, one of the things. I'm talking only about cloud. Cloud is contributing into this. There is very specific technology, CRI-O, Rockets, Containerd and Docker. So there are very, very specific technology. They are working only on containers, right? And Kubernetes is managing only containers. Understand? Those are very, very specific technology for container. So what we are understanding what cloud is doing. And then we will understand what Docker is doing on this. Then we will understand what Kubernetes is doing on that. Then only you will get a very, very brief idea. This topic, as I said, is a very, very advanced one, right? Is the future. But you understood now why it came into the market. What is the necessity? Now, how you are going to create the container? You are going to create the container from the image. Let me answer you people. Sir, what is the difference now here? What is the difference between App Engine, Kubernetes and Borsch? Harshal, I answered already. Akash, all the container will run on just one VM. Or can one container will run on a multiple VM? Image is similar to the package or artifact. Image is not similar. Image is basically a package of artifact, basically. If I say artifact, in case of microservices, my artifact is nothing but my image. Simple. And Akash is asking, is this container? Now see here, please remember. What do you want? Application. Application container, I am saying application container will have a limitation of handling certain users, right? If this container is not working, what will happen? End user will face downtime. So you don't want that. What you will do? You will create a clone, replica of a container. Similar container replicas you will create where? In a many environment. So how, in case what, when you need multiple VM, if your resources are, if your user base are more. So more user base means more replicas of instances you need, more copy you need, right? So it can serve end user. Now suppose you are selling some vegetable, right? Right? Yesterday I went to vegetable market. That's why I'm giving example, right? Now here on one counter, how many will be? 2, 3. Why? So they can serve end user, right? So in this case, One counter, one person is nothing but your BM. If you want to put a container inside one BM, right? Single point of failure, if you put in multiple, of course, you are serving it to the many users, right? You need to think in that way. Okay, Akash? Renu, single application needs one single container for all activity. Now here, please remember Renu, if I'm talking about a single application here, application is nothing but application is subdivided into small services. Small services are packaged together within the container. Architect is a little different. What I'm saying, application is divided into small microservices. These microservices are packaged together within the container. So now this container need to interact with one another. Why? Because front end container, back end container, payment gateway, right? So now here, so then they need to connect. Azure Cloud Registry, Azure Container Registry. It's a container registry. Okay, it's Azure Container Registry. Okay, so what I'm saying, what is the difference between container runtime and container engine? As the engine is used for pulling the image from the registry Docker Hub, does runtime need the same? Runtime will provide interface. Now here, what we need? Engine we need. What engine will do? Basically, engine will provide us host operating system and hardware. Basically, I say, what runtime will do? Which container runtime interface you are taking? What I'm saying, there are many provider. What provider? There are many container provider, right? Docker is not single one. Cloud is not single one, right? Or container D, cryo. There are many rockets, right? So what these are? These are container runtime interface, right? Which runtime interface you are taking, Binay? So that will decide your provider. Suppose you are taking Docker, right? Suppose you are taking Rocket, you are taking Cryo, that will be your container runtime. What is your engine? Engine will provide interface for your application to run, right? Can you, Anupam, okay, noted Anupam. Same container can be used by many user at the same time, right? But you need to create a replicas of application if your user base is more Avinay, your connection is, your knowledge is correct. Understood? So what I'm saying here, what is OS level virtualization? Please understand this here, right? You need to listen this recording again and again. What I'm saying here, what is this? OS level virtualization here is nothing but it will, now here virtualization is of two type, right? Hardware level, right? Because for virtualization, there will be another 4 or 5 sessions. Virtualization is not in syllabus. What I'm saying, now here, what this will do? Now what this will do, if I'm talking about, it will be in two type, OS level and hardware level. Hardware level virtualization will virtualize the hardware. So these hardware can be utilized up to their maximum potential. OS level virtualization will interact directly with the kernel of the operating system. So kernel of operating system can be shared between different resources. In our resources is nothing but container. It can be shared between different containers. So this is what we need to understand. Let's create, right? Let's create. So this is what I'm saying here, container instance, right? What I'm saying, resource group. What is my resource group? Can I write this is my container group? Container GRP here. I'm entering, this is my container GRP here. So this is what, and this is what, this is my container instance. So this is my, okay, let me put a container instance server, right? Japan East, it's okay. Let's put in Japan. If you want to put a scale keeping unit standard, what standard will do? Standard container group provide hypervisor level isolation recommended for most workload. And another one is we have confidential one for high security, right? For a high security and high grouping. Now, what we are doing? I am creating a server for what? Container. Server for a container. If I'm talking about container, for container, what I need? I need an image. From where you are taking an image, you can take a quick start image, or you can take image from Azure Container Registry. But to take image from Azure Container Registry, you need to push or pull image to the container registry. Do we have this? No. In the future, we will do that. Right? Project scenario. This is a project flow. Please understand. Or otherwise, I can use other registry also, but I'm using quick start image. Right? Now, what is saying here? Which image? I'm taking this image, right? There are some by default image, sample image we have, right? From the image, we will create the container. That container I'm putting for the end user. Where? By putting that into the server, right? So what size? Think now. I have this application. I'm putting this application on a 1B CPU, 1.5 gig of memory. How many user I can handle? 10, 20, 30, 40 maximum. Not more than that. If you need to add more than that, you have to scale up, right? You have to scale up. Actually, this is for smaller application architect. Something like static, some normal restaurant application type for smaller, right? Why you need to put more money, right? Here, costing will be less, right? Very, very less. Because of that reason, you can choose this architect to create a application. Networking, whether you are giving public, private, or this DNS level. What I'm saying, this is my container here. Continuously talk for 1.5 hours. It takes a lot of energy, right? And I'm going complete flow, right? So it takes a lot of energy. So now, why we need to keep, shall we keep port number 80 open? Because we are going to talk to the web, right? Please remember, by default, what is providing us? DNS. Domain name, by default, they are providing. It's okay. We are happy. Of course, they'll give us XYZ. Log analytics, please remember, monitoring will be by default, enabled for, by default, configured for all the services within this. See, what we got? We got our container instance or server. Create. Now, what is the workflow? What is the workflow? Image, right? Image. For this image, we are going to put inside the registry, right? This image will be inside the registry, right? From the registry, we are going to put inside the instance. Why? Because we need to put this application for the end user, right? Then end user will get the DNS. From the DNS, he will access the containerized application. Is it? So this is what. But in the future, you need to create your own customized image because own application, right? Own application. Then you need to push that into registry. From the registry, you can attach that with the instance. We have seen that option is here. Then we can run this. This is what the structure is, right? This is what the structure is. How you are going to give access to the end user here. Now, if I go to the resources, what I'll do, I'll go to here, right? Now, what we got here? We got this DNS, right? What we got? We got, sometime it will take time to configure. Now here, what we have? We got this. It will be accessible to the end user, right? Like this, you will get your customized application you will get, right? This is what we are not, this is what this image is not a customized one. So this is what we need to understand. So how to do skill up, sir, here? Don't worry, Pawan, follow me because we will go into Docker and Kubernetes. From Docker and Kubernetes, you will understand this. But why sir, then why you're teaching here? Because cloud is also working on containers. So because we are into cloud, that's why I gave you idea here. But actual thing will be Docker and Kubernetes. Sir, exactly what the container instance, Renu, container instance is nothing but I have an image. Image is nothing but indirectly if I say package of application. Why you have created package of application? You created package of application so that package of application can be delivered to the end user. Instagram, Facebook, why you are doing, right? Those package of application has to be accessible to the end user. This container, what this will do? What this container instance will do? Container instance will provide you that environment for end user here. Now I am an end user. I can do whatever I want within my application. Easy. So this is what, like this, right? Arman, 1 lakh rupees, 2 lakh rupees per month. It's not easy, right? You need to listen, follow every day. Let me answer them. You answer me after, ask me then. Okay. Akash, in the example, you have shown the BM will be created along the container. Okay. How we can use the same BM to deploy another container? See, auto scaling. This is the part of auto scaling. Here in container instances, we don't have this option. In container instance, we don't have this option, right? For this, we need to understand Docker Kubernetes, Akash. Okay. What are the interview question here, right? So see, you can filter out interview questions. What they'll ask, right? Shailendra, let me answer your question first. Okay, Shirisha, I'll ask your interview. I'll make interview questions. Docker desktop. What do you mean by Docker desktop? Docker desktop, please understand. Docker desktop will install Docker engine. Docker engine will provide, of course, you knows what Docker engine will do, right? Docker engine will interact with the kernel of operating system, right? What Docker desktop? Docker desktop will provide environment on window. What Docker desktop will do? Docker desktop will be installed on window environment, right? What Docker desktop will do? Docker desktop will install the Docker engine. Docker engine will interact with the kernel of operating system. So your container will share same kernel, right? Your container will share same container. How much memory storage it will take container? See, Sharad, it will depend upon container to container, right? It will depend upon your application to application, right? How big your application are, how big your image are, how big your container are, it will depend upon that, right? Fair enough. So this is what about registry? Sir, while creating a BM for Linux is not getting the private key to download. Renu, what is the problem? What can be the problem? Why you're not getting private key to download? What's the problem? You're missing something, Renu, then, right? You're missing something. Who is asking me an interview question? Remind me, please. Okay, remind me one more time. Who is asking me? Shirisha, remind me, please. Okay, just give me some time. I'll give you in the end. So what I'm saying, you're doing some mistake, Renu. You're doing some mistake. Okay, what mistake I'm doing? Check, cross check. What I can help you here? See, if you're going to the BM, right? Virtual machine. What is how it's not doing, son? Now what I'm doing here? I'm creating in front of you. Now notice carefully what I have. I'm clicking on virtual machine here, right? I'm adding one resource group. I'm just taking a random resource group, right? I'm putting one random name, right? Each and everything is okay. Please cross check here. Okay, please cross check here. You have to enter the name, but still he'll ask you. I don't know why he's not asking. So now here, what I'll do, review and create. If I'll do a review and create here, it will ask me. What it will do? Now here, it will ask me to, now here, as soon as I'll click on create, right? What it will ask? It will ask me to download the key. I don't know what is the issue. Find out. Hey, here what I have. Private key and resource group, right? So this is what. Okay. Yes, Binay said something. Shirisha, notice this, please. Yeah, your pop-up might be blocked. Okay, check here, right? Your pop-up might be blocked. Don't block that. You need to unblock that. Okay. Okay, Renu. Yes. So now another thing here. What are the interview question? Possible interview question. First thing is, what do you mean by containers? What is container? Right? And what is the necessity of having containerization? What is the difference between what do you mean by package of application? Right? What do you mean by package of application? What Docker engine will do? And what do you mean by more monolithic and microservices here? What do you mean by image? What do you mean by container? What do you mean by registry? Why we are using registry? Why we are using image? Why we are using containers? Right? So these things. But here question are not many, but your explanation are much, because you have to explain many things. Okay. And this will be repeated one more time. Why I didn't said this? Because I don't want you people to be lazy. This will be repeated one more time during Docker and Kubernetes. Don't worry. Okay. This flow I'll repeat one more time. So you will be comfortable. But don't rely on that. Okay. Today means understand today. Okay. So this is what. And what about ACR, sir? Can we create ACR? Yes, we can create. I created container instance, right? Container instance. This is for, you need to understand scalability for mid-level. Uh, Arman, delete all of them. Okay, delete each and everything. Don't worry, this money is a lot of money, but still delete this. Okay. Now what I'm doing now here, let's understand. I'm talking second container services, right? What that is? Container registry. Container instance we understood just for a mid-level application if you want to deploy. Yeah, yeah. See here. What is now? They are giving you domain name. Why you need public IP? If they are giving you domain name is why you need public IP? I'm going to the container registry. Please remember, geo-replication is possible in container registry. What is the meaning of this one? From one region to another region, your registry can be replicated, right? Latency will be zero. Latency will be zero. So what I'm saying here, this is my registry GRP. I'm saying to the old batch, I'm saying to you people, I'm saying to the future batch. Explanation will matter how you are tackling your answers, what your explanation are. That will matter in a big way. Understand what I'm saying? This is my, can I enter? This is my class registry. Somebody was asking me Azure contain cloud. See, somebody was saying Azure cloud registry, right? It's a container registry. Okay. You made me confused actually. I started doubting myself. Okay. I thought, is it cloud? Because I thought, no, it's Azure container registry. Please remember. Okay. I can be wrong also, right? Right. I'm not a God, right? So I can make a mistake. What I'm saying. So this is container registry. What he said. We cannot have a special case number, right? We cannot have special case letter. This is what, let's keep in Japan, right? Domain level, what do you want? Tenant, subscription reuse, right? What you can do? Networking, whether for public or private, right? Review and create. Not very different. What this is registry here, right? But what is the positive? What is the registry flow? Okay, this is the registry to store the image, right? But very good. Why we need this? So in the future, we will save the image. But how? We need to create a CI/CD flow as well. Okay. So many things will enter here as of now. Don't worry. Understand? So ACR, right? In ACR, what we have? Azure Container Registry. And depend upon size, right? Straight away. Depend upon size, right? There are more than 1,000 you can store here. Okay. Whenever we are talking about specific numbers here, depend upon size. But here we can store. So now you need to read this article. Okay. What you need to read this article here if you want to get proper information. Okay. Geo replication redundancy. This is for multi-image archiving here. Image. Please, I'm giving one assignment. Please find out how many image we can store within the ACR. Okay. How many by default number? I'm wanting you people to find out the number. Okay. Please find out the number. So means where we will get this tomorrow. Let me know as well. Okay. Please let me know tomorrow. How many images we can create within the ACR? Okay. Give me one number tomorrow. So now where images will be? Inside the repository. There will be one repository here. Within the repository it will be. Understand? So then who is asking? Memory. Need to enable pop-up if block. Okay. Cross check. Thank you, Renu. Shirisha, what is the difference between container and artifact, sir? Now see here. Artifact is a package of application. Artifact is a package of application. But in case what? Monolithic architect. Artifact is a package of application. If I say the container, artifact is image. Artifact is image. From the image, we are going to run the container, right? But in this, see what artifact is basically. Artifact is a package of application, right? If I'm talking about monolithic one, architect will be artifact, or this artifact will be package of application. In case of container, my package will be image. From the image, I'm going to run the container. Container is nothing but a separate environment, independent environment for application to run, right? A package of application in one customized environment. Okay. For small level, yes. Yes. Container instances, Pawan, yeah. Babab, what is the difference between Azure instances and a registry? Babab, registry, why we are using? Registry we are using to store the image. Instances, to put that image for the end user. End user will get domain name, right? You need to, why we are creating image? We are creating image packet of application so it can be put it to the end user. But how you are going to put that, you are going to put within the Azure instance. Sir, Docker image is a blueprint of creating yes, Sampurna. Kubernetes automate to adjust number of container on demand. Is it correct? Yes, it will do auto scaling, scale up, scale down as per our requirement, as per our request. Correct, Sampurna, right? You will understand more about this in the future, right? Today, you are in a position to understand something. Up to storage limit. Azure Container Registry, Harshal, allowed to store many container images up to registry storage limit. That's what I'm thinking. What is the storage limit here? Because whenever you are creating ACR, now here, let's understand here. Okay, if I'm going to the ACR, right? Understand here. If I'm going to the ACR, Azure Container Registry, right? If I'm clicking on what I'm clicking on, if I'm clicking on this here, do we have any storage limit here? No. See, do we have any encryption? See, we don't have any storage. Understand? We don't have, this is what I'm talking. Understand? So by default, this is what. Okay. If I'm going here, this is my registry here, right? Under registry, I don't have any storage things. Right? So this is what I'm talking. Okay. Explore, please. Sometime you will not understand concept. You need to listen again and again. Because you are getting lot of content within a span of 1.5 hours. If I says, if you take in a positive way, it's very good because I am saving your time, right? You are learning technology very fast. Negative thing is, I am going, negative thing is you are getting more content within 1 hour, 1.5 hour. So one negative thing, you have to revise each and everything again and again. See, otherwise you have to explore by yourself. It will take time, or I am giving you something within a span of 1.5 hour. You need to explore. If you want to grow faster, you have to explore faster. That is what the end target is. Understand? So this is what. Okay. What about others? Sir, one query for previous. Shirisha, go on, please. I was not unable to delete storage account in a way to delete because why you was not able to delete the storage account? Because you have enabled. I told you this. I gave this assignment to you people actually. You are not allowed to delete the storage account. Why you are not allowed to delete the storage account? What you have to do, Shirisha? You have to create. Let me go to the storage account here, right? I think many of you, Shirisha is honest because Shirisha tried. You people have not tried this, right? That's why you're not getting this question. I know this, right? What I have, this is my storage account name, right? What I'm putting this is my resource group. I'm putting a storage account DRP, okay? Not Ansible one, it will not be better. What is my, I'll do what I'll do. I'll do a storage account GRP, right? What I'll do. Please remember, whenever you'll create a storage account, in storage account, we will have a file share. Actually, it's not, you are not allowed to delete the storage account. You are not allowed to delete the file share. Why? Because in file share, you have created the backup. You have to delete the backup. You have to unlink that file share from the storage account. Then only you are allowed to delete. See, I'm giving you medicine, Shirisha. What you need to do, Shirisha, do what you need to do. You need to go to the file share. Okay, try to delete that first. Okay, then tomorrow I'll show you. Remind me this. I'll show you practically. Okay, I'll show you this practically. Right? Listen this. What I'm saying every day. Right? Interview question you can filter out. See, I'm not a big fan of interviews. What interviews are? Relative will be from topic, right? It will be from topic. If your topic is good, you can filter out. Understand? What he will ask, I don't know, right? So, but he will ask from this topic, that is for sure, right? So, how we can cover? What he can cover? I covered each and everything, right? Try to ask. Not even interviews know these things. Will be confused what I'm talking about, all right? And this is what. Please explore. I'll catch you people tomorrow. Please listen this very, very important session. This is because containers are very, very high end technology. It will stay for longer duration of time. Yes, Shirisha, you need to try that. Okay, try that. Soft delete will not work. You need to delete file share. Okay, you need to try. You need to try file share. Okay, you need to delete file share. Then only you are allowed to delete. Otherwise, you are not. Okay. Okay, I'm dropping the session here. Please listen carefully. Okay. And whatever I said, please correct yourself and prepare your presentation, how you can present your knowledge in front of somebody. The way I'm doing, you people need to do in the same way.